We're going to answer question B. We're going to solve the linear system 5x minus 3y minus 9 equals 0 and 4y plus 9x equals 82. And we're going to do it using the method of elimination. First thing we do is label our equations 1 and 2. It helps us to stay organized. And what we're now going to do is rearrange equation 2 to line it up with equation 1. See, I notice I have my x term starting equation 1, but my y term starting equation 2. I don't want that. I want my x terms to be switched with my y terms. And then I also notice that I have minus 9 on the left side and equals 0. For equation 2, though, I don't have any constant term to the left of the equal sign, and then I have 82 on the right. I'm going to rearrange that a little bit too to line it up. So rearranging this, I'll call it 9x plus 4y minus 82 equals 0. And I've now rearranged equation 2. I've left equation 1 the same and rearranged equation 2. The reason I did that is now I have my x terms lined up, my y terms lined up, my constant terms lined up, equal signs lined up, and zeros lined up. Alright, now I have a decision to make. Do I want to eliminate x's or y's? Eliminating x's will require a coefficient of 45 because the lowest common multiple of 5 and 9 is 45. That's a pretty high number. Eliminating my y's will only require a coefficient of 12 because the lowest common multiple of 3 and 4 is 12. I like that idea better. So I'm going to multiply every term in equation 1 by 4 to give me a coefficient of 12 in front of the y term, and every term in equation 2 by 3 to give me a 12 as the coefficient of the y term. Okay? So that ends up multiplying every one of these terms by 4 gives us 20x minus 12y minus 36 equals 0. 20x minus 12y minus 36 equals 0. And multiplying every term in equation 2 by 3 gives us 27x plus 12y minus 246 equals 0. Okay, and that's what we did. What that's now done is it's lined up our y terms and our x terms. But it's important now, instead of subtracting, we're going to add these two equations together. The reason we're going to add is because the term that we're seeking to eliminate has different signs in front of it in each equation. There's a minus in front of the first 12y, but a plus in front of the second. We want to add negative 12y and positive 12y to eliminate the y terms. If we're going to add them, we should add everything. So 20x plus 27x will be 47x. Negative 36 plus negative 246 will be negative 282. And that'll equal 0. Well, this is a pretty straightforward equation now. 47x minus 282 equals 0. Adding 282 to each side means 47x equals 282. We can subtract each side by 47. It looks pretty ugly, but fortunately it works out nicely. X is simply equal to 6. We can then take that value of 6, substitute it into either of the original equations we started with. So this was one of them. 5x minus 3y minus 9 equals 0 was one of our first two equations, so we use that. Subbing in a value of 6 gives us 30 minus 3y minus 9 equals 0. And we now collect our like terms, divide through by the coefficient of y like we normally would, and y equals 7. And since we're solving a linear system, we know that we have to have an x value and a y value, so the solution to the linear system is the x, y values of 6, 7.